Hello everyone, and welcome to the videos for the review packet for cumulative test number 3. Let's go ahead and get started so you can use your time efficiently, shall we? So this first problem goes back to the first week of school where we were converting fractions, decimals to percents, and really any of those to one another. In this first example, we have 66%, and if I want to change 66% to a decimal, remember that the decimal currently for a percent is here. So if you're making the number smaller as a decimal, you move it 2 to the left because a percent means out of 100. So the answer here is 0.66. And if you wanted to change this into a fraction, you could either look at this place, or 0.66, and say that, okay, this is in the tenths, in the hundredths place, so it will be 66 out of 100. Or you could look at this percent and remember that, again, the percent means out of 100. So you could also say from here that it's 66 over 100. But if you remember fondly, we can't leave it like this because you can take at least a 2 out of both of these. So 66 divided by 2 is 33. 100 divided by 2 is 50. So the most reduced fraction is 33/50ths, and this is the answer for my decimal. The second example, 17/40ths. Remember that a fraction is really just division. And so this is when I would pull out your calculator and take 17 divided by 40. If you do so, in the calculator, you would get 0.425. So a little note that I did this in the calculator. Here is my decimal answer. So now if I want to go from a decimal to a percent, I'm getting larger. And so if it's currently 0.425, you move the decimal twice over to the right, again, out of 100. So my answer will be 42.5%. Last but not least, the third example in this box, 0.143. If you're going to change that into a fraction, we have 1, 2, 3 decimal places behind the decimal point. So that would be 143 over not 100 this time, but 1,000 because the 3 decimal places. I look at these two numbers, notice this one's odd and this one's even, and I can't think about anything that goes into 143 and 1,000. So this, strangely enough, is going to be my most reduced fraction. If I want to change from a from a decimal into a percent, like the last example, we just move the decimal over twice to the right, so it'll be 14.3%. Next example, simplify by using the order of operations. And remember, these are not equations. All we're doing is simplifying and solving. So order of operations, PEMDAS, we want to always do parentheses first, then exponents. Multiplication, division are on the same level, and addition, subtraction are on the same level. So when they're on the same level, remember that you always go left to right. So for number 2, for example, I noticed that we can simplify inside parentheses first. So we'd have -4 squared, and I'm just again going to recopy everything that I see. The next thing I notice is we do have an exponent. So let's simplify this piece. -4 squared is a -4 times negative, so it'll be a positive 16 minus 8 divided by 4 times 2. In terms of what comes next, we're between subtraction, division, and multiplication. Subtraction definitely comes after multiplication and division. So if I'm between which one of these to start with, we would start with the division first because it comes first left to right. So we'd have 16 minus 2 times 2. Now if we're between subtraction and multiplication, we would multiply next and get 16 minus 4. So this final answer is 12. Number 3, remember that a big division symbol is another grouping symbol. So we do the top and bottom separately and then simplify at the end. So in the numerator, we have division, multiplication, and addition. This division is going to come first. So we'd have 2 times 2 plus 3 on the top. And in the denominator, I'm going to simplify the parentheses to be 3 times 7. In the numerator, multiplication comes before addition. So we have 4 plus 3 on the top. And on the bottom, this multiplication is 21. This ends up being 7 over 21. This looks like it could be a final answer until you realize that 7 goes into both itself and 21. So if you divide both pieces by 7, your final answer will be 1/3. Numbers 4 and 5 ask you to completely simplify the following expressions. Now notice it says expression, not equation. So I'm going to write a note. It's not an equation, so you're not solving for x. All we're doing is combining like terms and simplifying. So if I looked at number 4, I noticed that 3x squared and negative 8x squared are like terms. If I combine 3 and negative 8, I have negative 5x squared for my first term. I noticed that negative x, or x to the first power, does not have any buddies, so I'm just going to write minus x. But 9 and negative 27 can be combined, and if I combine 9 minus 27, I would get negative 18. And this is my final answer again because I am not solving for x, and everything at this point cannot be combined. Number 5 is asking you to do the same thing. Let me distribute first and then combine like terms. If I did that, I would get 12 minus 18x minus 40, and then negative 4 times negative x is positive 4x. Please, please be careful about this. Now if I were to combine like terms, negative 18 and negative 4x could be combined to be negative 14x. Positive 12 and negative 40 would combine to be a negative 28. Final answer, because again, we are not solving for x, we are just combining like terms and simplifying. The next examples you might remember from when we first started doing absolute value that we did the order of operations with absolute value. And so our first goal is to plug these numbers in accurately. So we want to find the value of this absolute value. X is 5, so the absolute value of 5 minus 4 plus the absolute value of y, negative 3, minus z, which is 6. And remember, the grouping symbol or an absolute value bars are grouping symbols. So let me keep simplifying in here and in here. So we'd have the absolute value of 5 minus 4, absolute value of 1, plus the absolute value of negative 3 minus 6 is negative 9. Remember that absolute value, again, means distance, and distance is always positive. So if I take the absolute value of positive 1, the answer I get out is positive 1. If I take the absolute value of negative 9, distance is always positive, so that is really a positive 9. So if I add my like terms, my final simplified answer is 10. In this next example, again, let me plug in what I know. 2 times the absolute value of negative 3 minus 5 plus 3 times 4 minus negative 3. Inside this absolute value bar, the double negative does become a positive, and let me simplify within the bars next. So I'd have 2 times the absolute value of negative 8 plus 3 times the absolute value of 4 plus 3, or 7. Order of operations tells me, let's worry about the grouping symbol first still. And then the 2 is multiplying this result. So the absolute value of negative 8 is positive 8, and that is being multiplied by 2. Plus, the absolute value of 7 is a distance of 7 multiplied by 3. So now we multiply to get 16, multiply to get 21, and if we combine these like terms, our answer would be 37. So please just be careful that remember that absolute value is always positive, so make sure when you're doing the order of operations that these two values here become positive. Solve each equation for the given variable. You might also recall this from earlier in the year. If my goal is to solve for x, I want to get all the x's on one side, all the other letters on the other, and I want to get x completely alone. Now this problem I remember we had on test number 1 at least, and on that review packet. So if my goal is to get x alone, let's at least again get the x's on the same side. So we'd have mx minus nx plus a equals negative b. My next move to get x by itself would be to scooch the a to the other side by subtracting. So we'd have mx minus nx equals negative b minus a. At this point, we wanted to go from two x's to just one. So what we took out was the greatest common factor and said, okay, the greatest common factor in these two terms is x. And if I take that out, if I take x out of mx, I'm left with m, minus x out of nx, it's just left with n. Recopy. My last move would to get x alone would be to divide by m minus n. So on both sides, you get rid of that by division. So we'd have x by itself equals negative b minus a over m minus n. This is the final answer because x is now alone. Number 9, my goal is to solve for y. So if I look at this ginormous fraction, I'm guessing the first thing I want to get rid of is w. And I'm not guessing, I know that the first thing I want to get rid of is w. And if I do that, the w is crossed out over here. So I'd have 5y minus 7x equals 4 times n times w. That should be a 4. If my goal is to still get y alone, the next thing I need to do is move the 7x by adding to the other side. So we'd have 5y equals 4nw plus 7x. My last move to get y isolated would be to divide everything by 5. So y is now alone, and it equals 4nw plus 7x, all divided by 5. These two word problems. Next. Jim's car used 6 gallons of gas in 5 hours. At this rate, how many gallons of gas will the car use in 11 hours? So I think this is going to be a proportion problem, especially if you use units, because we have 6 gallons of gas in 5 hours, so 6 gallons is to 5 hours as, or equals, how many gallons in 11 hours? Now some of you might remember in class I said that you don't need the units at this point, so you could write a different proportion. 6 is to 5 as x is to 11. And if we have a fraction equaling a fraction, that's when cross multiplication is applicable. So we'd have 5 times x equals 6 times 11, or 5x equals 66. And if I divide both by 5, 66 divided by 5 is 13.2. But because this is a word problem, it would be 13.2 gallons. Or technically 13.2 gallons in 11 hours. The last problem we're going to do on this video is the consecutive integer problems. And again, I'm going to do it the algebraic way just so you can see it again. The sum of 3 consecutive even integers is 108. So remember, sum means addition, or the answer to an addition problem. If I'm talking about consecutive even, these are 3 numbers on a number line, like 2, 4, 6, that are all even and next to each other, so they are all 2 units apart. So if we don't know what these numbers are, what I did in the past was I said that the first number was x, the second number was 2 units later, or x plus 2, and the third number is another 2 units later, which we represented as x plus 4. And so if the sum is 108, that means that I know that the first number plus the second number plus the third number equals 108. If I do some substitution, that would be x plus 2 plus x plus 4 equals 108. Combine like terms. 3x plus 6 equals 108. 3x equals 102. If I divide by 3, I will get that my first number is 34, which means my answer would be the first number is 34, the second is 36, and the third is 38.